In HOT, European universities are working together with the industrial giants IBM, ST Microelectronics, Hitachi, and Thales SA. The Hybrid Optomechanical Technologies project brings together 17 research groups in 11 countries. They have demonstrated proof-of-concept devices with potential market readiness in the near future. But what are HOT devices? Modern communication runs on optical fibers. We depend on light to catch up with friends and watch cat videos. Unlike in sci-fi movies, crossing beams of light achieves nothing, so we can send lots of light on one optical fiber. However, light can push tiny mirrors, like wind on a sail. This radiation pressure allows light to interact with itself. A beam of light hitting a mirror moves it. The direction of a second beam then changes depending on where the mirror is. By interacting with a moving object, the first beam has affected the second. This moving object acts as the medium that gives rise to an effective interaction between the two light beams. This brings us to the optical circulator, which acts as a roundabout for light. HOT circulator uses a microscopic silica toroid in which light can circulate 100,000 times. Just like we saw earlier, light transmitted through this device can be controlled by another light beam with the help of mechanical motion. This control beam induces unusual behavior. When light carrying a signal enters the device, it can be transmitted directly or converted to mechanical vibrations and back to light. These two pathways can interfere constructively or destructively. As a result, light entering port 1 exits through port 2, where the interference is constructive, and not port 4, where it is destructive. Light entering port 2 is routed to port 3 instead of 1. This circulator is a non-reciprocal device. Since light can go from port 1 to 2, but not vice versa, it is unique because it does not use magnets and is controlled using light itself. Hybrid Optomechanical Technologies have several other applications. Over the coming years, HOT will be investigating hybrid sensing devices, as well as enhanced positioning systems that are ideally suited for mining and navigating deep underwater. These devices will revolutionize the internet, making it run more efficiently. Light is also an ideal carrier for quantum information, so these devices, as well as other devices under development by HOT, can pave the way for a quantum internet.